Hey guys, welcome to Unit 3, Probability. So let's start off with some basic probability and some vocabulary. So the word event in this case means the outcome of an experiment. So the outcome of the experiment of tossing a coin, one event would be heads, one event would be tails. When you roll a die, events would be 1, 2, 3, 4, 5, and 6. A random experiment is uncertainty over which event will occur. So tossing a coin or rolling a die, like I just mentioned. Probability is always between 0 and 1. If probability of something is 0, it's impossible. If the probability of something is 1, it's certain to happen. And of course, if the probability is 1/2, it's somewhere in the middle. A sample space is a list of all your possible outcomes. So if you are tossing a coin and rolling a die, it would be like heads 1, heads 2, heads 3, heads 4, tails 1, tails 2, tails 3, tails 4, and so on and so forth. Relative frequency, we're going to talk about this a little bit more, especially at the end of the lesson. It's used to estimate probability. So the larger the number of trials, the closer to the actual probability that we're going to have. So here in a little bit, we're going to see a frequency table, and then we're going to calculate relative frequency from that. And then we'll be able to find probabilities of different events. Okay, so some things that we need to know, some facts and formulae. By the way, plural of formulas, formula is not formulas, it's formulae. Fun fact. Okay, so first of all, P of A, that means probability of event A. Probability of event A occurring, the way we're going to find that is we're going to have the number of ways A can occur. Divided by the total number of outcomes. Also, if you want to find out how many times something is going to occur over n trials, like how many times will you roll a 6 if you roll a die 100 times? Or how many times will you get heads when you flip a coin 50 times? So probability over n trials gives you a prediction of how many times that particular outcome will come up over so many trials. So n is the number of trials. And P is the probability of that event occurring. Good deal. Okay, so a fair 20-sided die with faces numbered 1 through 20 is rolled. The event A is defined as the number obtained is a multiple of 4. So we want to find the probability of A. So first of all, and it's not that this matters very much, but I just want to point something out real quick. Let's talk about what the sample space is of this guy. So sample space is a list of all of your outcomes. So we could get 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 20, right? So how many ways can we have a multiple of 4? Or how many multiples of 4 are there on a 20-sided die? 5 multiples of 4, right? So that means 5 is going to go on top, because that's a number of ways. a multiple of 4 occurs, over, and then the total number of outcomes, well, if it's a 20-sided die, that's going to be 20. Then we can simplify that, divide both the top and the bottom by 5. We'll get 1/4. Okay, now that die is going to be rolled 100 times. How many times would you expect to get a multiple of 4? So this is where we're going to take the number of trials times our probability. So we're going to have 100 trials times our probability of 1/4. So we'll end up with 25. That's how many times you would expect to roll a multiple of 4, 25 times. Okay. So the colors of cars that are passing the school gate, that should be a T, not an M. Sorry about that. Boop, boop. Okay. One morning are given by the following table. Estimate the probability that the next car to pass the school gates will be red. So first of all, before we actually get to A, I want to talk about frequency versus relative frequency. So here's this table. So frequency is how often that occurs, right? So there were 45 red cars, 16 black cars, 2 yellow cars, and so on and so forth. And then we can see down here at the bottom, we have our totals, right? Well, earlier we talked about relative frequency. Relative frequency is used to estimate probability, and the larger the number of trials, the closer to the actual probability. So relative frequency is essentially finding the probability that the next car will be whatever color this is. So the way we'll find that is we're going to take our frequencies and divide by the total. So to find out the probability that the next car is going to be red, or find its relative frequency, that's what we're finding right now, relative frequency, we're going to take our frequency, 45, divided by our total. So 45 divided by our total of 138 is going to give me 0.326, so 0.33 for my relative frequency of getting a red car. Relative frequency of a black car, we'll take 16 divided by 138 and get 0.1159, so maybe 0.12. So that's the probability that the next car is going to be black. Yellow, we'll take 2 divided by 138. Get about 0.01. Relative frequency of getting green, or the next car being green, 14 divided by 138. About 0.1. Relative frequency of blue, 0.12. Relative frequency of gray, 23 divided by 138. 0.17. And then whatever other cars there are, 21 divided by 38. It's about 0.15. Now, if you add together all of those probabilities, that total is going to become 1. Because, remember, certainty is 1, right? So if we add up all of the different probabilities for a situation, they should add up to be 1. So that relative frequency that we just found, that's essentially the probability that the next car is going to be that color, because we're going to take the number of ways that we could have gotten red. There was 45 red cars, divided by our total of that 138, and that gave us 0.33. That is not where that's supposed to go. I'm so sorry. We had 45 divided by 138. So we ended up with 0.33. Or you could put that as 45 over 138. All right, now if 350 cars pass the school gates, estimate the number of red cars. So this is, again, going to be one of those n times p, the number of trials. So that means 350 trials of 350 cars driving by, times our probability, which was 45 over 138, or 350 times 0.33. And if we pop that into our calculator, we'll end up with 114 red cars. All right, next time you can see, we'll talk about Venn diagrams. See you later.